Hello, everyone. Welcome to Snyk Live. We have a very special show for you today. Eric and Adolfo are going to be talking about Sigstore, some Docker and Kubernetes fun stuff headed your way. Hope you got your YAML files ready. So without further ado, I'm going to bring on my good friend and co-host here, Mr. Eric Smalling. Hi, Eric.
Good morning, Kyle. Good afternoon to everyone on the... It's not quite afternoon for you yet, is it?
It's noon, so we'll call it.
Okay.
We have a really special show today. As we all know, there have been a lot of interesting developments. I think, on May 3rd, like Kubernetes 1.24 dropped or something like that, somewhere around there. And there were some major developments as far as Sigstore goes, and the adoption has been massive. So I think let's bring on our special guest to talk about that. Welcome, Adolfo, to the stream.
Hey, hello, Kyle. Hello, Eric. Thank you for having me.
Hey, thanks for joining us.
Awesome. So, Adolfo, can you tell us a little bit about what you do?
Yeah, well, in my day job, I am a software engineer with ChainGuard. We're a company specializing in supply chain security. I am also one of the technical leads for Kubernetes SIG-Release, where I've been working on improving the security of the Kubernetes releases for, some years now, I think.
I know what Kubernetes is, and I know, CNF, and we all do, but just for anyone who's joining that might be new to the Docker Kubernetes world, Kubernetes is an orchestrator for containerized workloads. I mean, it does a lot of things, but that's its main purpose in life. And it is a very distributed platform, if you will. It's got a lot of Go application bits that get packaged up and built by the release team. It is part of the Linux Foundation CNCF Foundation umbrella. So Adolfo, you've said you've been with the release special interest group, right? How long have you been with them, and how did you get involved with Kubernetes?
I started approaching the Kubernetes project in 2017, 18, I think. Okay. First, I started getting involved with Gates Infra group, which is the folks that manage the Kubernetes infrastructure. At that time, it was a work group. Now it's a full-blown SIG, special interest group. And then from then, I started getting involved with SIG-Release. I was part of the Kubernetes 1.18 release team, and then started collaborating with the people there who are now very dear friends of mine. Just getting in more and more contributions and helping build the tooling that releases Kubernetes. Time I became a release manager. First, a release manager associate, release manager, and then a technical lead for the SIG. And then for the past, I think 2 years or so, we started working as the whole industry, right? Started looking into some very interesting developments and new technologies and proposals for securing the supply chain of all the software in the world, but in our case, for Kubernetes, because we were the SIG that was ideally placed to do that. And so we started looking into things like building SBOMs for the project, signing the artifacts that we put out, things like improving our processes to be compliant with things like Salsa, for example, which is a security framework, which we can also discuss if you think it's interesting.
Well, it's cool. I mean, the way Kubernetes releases work, there used to be 4 of them a year, and now there's 3 as of last year, I believe.
Exactly.
And explain a little bit about how the CAP process works. How do features and enhancements and fixes get slated for a release in Kubernetes?
Okay, yeah. So signing the Kubernetes artifacts has been a recurring issue in many shapes and forms for years now. We had an issue to sign, I think, artifacts using GPG open for I think 5 years now or so. But signing things is hard because it involves lots of trust issues. It involves key management. It involves securing the process and access to those keys. I mean, the issues were open. For example, right now we are working on, so part of the Kubernetes releases involve putting out devs and RPM packages for Linux distributions. And currently those packages are signed by Google, by actual Google employees who run internal tooling that signs those packages and upload them to their repositories. We are in the process of moving those packages to community-owned infrastructure, and they're going to be signed with a community-owned key. So it was comparing that with the signing of artifacts that we currently do was like reliving all of those days of GPG things and things like that, which now Sigstore makes so easy. We started the discussion over there, and so we opened 2 caps, one for signing the artifacts, and that cap is itself part of this other cap, which is the Salsa Compliance Gap, which is an overarching effort to secure all of the release process of Kubernetes. So we were working on that project like for a year, probably a little bit more. Essentially, since Sigstore was in its early days, we started the discussions with them on how we could collaborate and how our tooling and their tooling could fulfill the technical tasks that we needed to do. And it's been quite a journey ever since.
Sorry, Eric, I'll pass it right back to you. But for folks who don't know, Salsa Compliance is, and this is a long acronym, supply chain levels for software artifacts. That's Salsa. So as we know, supply chain is, all the things that come together and eventually, make up your product, your project, your application at the end of the day. And software artifacts, of course, are, software artifacts. So it is pronounced like the food, and it's just as delicious. But basically, what it is it's a set of compliance standards to improve Kubernetes software supply chain security, and it's a checklist of standards and controls that prevent tampering, improve integrity, and secure the packages and infrastructure in your projects.
Supply chain, I've joked for the last 12 plus months, KubeCon and other conferences, you could probably have side conferences called Supply Chain Conf, because it seems
there are actually.
Yeah, exactly. You're right. So now there are. But I was interested. You mentioned that discussion about signing Kubernetes artifacts has been around longer than the White House mandate and the SolarWinds exploit and things that were that really popularized the need for hardening supply chain. I've been talking supply chain as it would be nice to have for a long time. I'm intrigued to hear what were the conversations 5 years ago that actually got people on board that early. Do you have any insights as to who was asking for it? Were you one of the ones asking for it? How did that start?
When I got into the project, the issues were already open.
Okay.
And so signing software artifacts is not new. Since the early internet FTP days, you could download a PGP sign binary. And while we had issues open for signing things using GPG, I think the overarching spirit of that was we want integrity guarantees on the artifacts we're downloading, be it as a GPG signed artifact or any other schema that you want. But it was kind of difficult in the sense that, it's a lot of work because you have to establish technical key handling. You have to design protocols of who has access to the keys. How are you going to pull those keys into the signing processes? Are you going to be signing things in some guy's laptop somewhere? Are you building this into your release process? Kubernetes, it may be one of the largest open source projects in the world, but it has the same pain points as other open source projects, and mainly it's the lack of developers and the lack of contributors. There's lots of people working on Kubernetes, but still it's a really large project, and all of the teams are spread really thin. So it's not easy.
The important thing about signatures is not just that you have it, because anyone can make a digital signature of something. It's the trust. Do you trust who signed it? And we know that through, SSL implements that with the browsers. You know that I trust that this is my bank because somebody that I trust certified the signature, right? It's having those. Everyone thinks about Sigstore, they think about the Cosign tool and how easy it is for, as a developer, I could pick up and use. But that backing of Recor and Pulsio and all the things that are happening behind the scenes are what make it powerful and make it useful. Sigstore, the project, is hosting those services for free right now. Is that going to be, how is is that, I mean, how do I word this? That's great for open source projects and development. What if I'm an organization that wants to, can I host my own copies of those things? And how do you see that happening? I mean, I know you were ChainGuard, and I don't want to turn this into a ChainGuard company thing, but that's what I would think as, coming from the enterprise space. I may not want to rely on an external Recore and full CO.
No, I mean, not in particular cases, but some people have voiced that, and yeah, and the project is designed to be able to be used. So you can use any of the Sigstore components separately. So
Right.
you can run your own full CO instance if you want. There are things like Terraform. There's Terraform code to deploy your own Sigstore components. There's I think there are, if I remember correctly, there were Helm charts to deploy some of the components. So you can absolutely go and deploy your own Sigstore instance internally, which doesn't have to necessarily rely on the public infrastructure. When we started building some of these things, we really rushed to get things in there, and as trailblazers, we hit a lot of mistakes. Some of the architecture initially was wrong, and we've been correcting, and we now have like a really nice development plan, which I'm confident we can now share with other projects.
Cool.
And I'm actually working right now on the last missing piece, which is an attestation building for Builder, which allows you to express the transformations you did to your source code to get it into usable artifacts, and that is the concept that gets attested in a file, which you then sign and provide to downstream consumers. And so Kubernetes is gonna get that project. I'm hoping to start the donation of that project next week, and that project will be able to generate attestations, which you can sign using Sigstore and then attach to your artifacts. And yeah, so most of this work has been in coordination with the security tag in some way or another.
I was hoping we could talk a little bit about like the way that Sigstore deals with like trust anchors, right? So trust anchors are things that we assume to be secure, and we derive our trust in something from the security of the trust anchor, right? So whether that is the how hard it is to get two 100-digit prime numbers from the product of those two numbers, right? Maybe we should talk a little bit about that, because I think that's kind of interesting. So like the Sigstore root key is made up of like 5 key holders in the community, right? And that's all like publicized on GitHub. So you can actually see who owns the keys, right? So they're operating in plain sight. So I think that's really interesting, and it very much, is like a community initiative. The keys are held by community members. And so I just think that's really, really interesting and like super unique, because like Eric was saying, it's great to have signatures, but how do we know that we trust, things are what they say they are?
So what I have, it doesn't matter what's in it. It's a Java app, but it's a container that I just built. And what I want to do is I'm starting from a clean slate. I have Cosign installed. For those who care, I'm on an M1 Mac that's running Homebrew. So I just did brew install Cosign, and I'm running Docker Desktop. That's how I built the image. And I'm going to be pushing this to my personal Docker Hub account. Okay, I've not pushed this image anywhere yet. It's just sitting locally. What would be my first step? And I'm kind of interested, if it's not too complicated for this, to use the keyless signing functionality, to use maybe my Google OAuth for that. What's my first step? So if I know if I do a Cosign help, I'm going to get a lot of stuff. But
yeah,
where would I start?
So the first one is, I'd recommend that you push the image to where you, because you're going to be attaching that signature to the registry where that image lives.
We'll do that, and I've already logged in, so I
So-
don't have to give away my key like I might do.
Yeah, so some of the as you just showed, Cosign has like lots of functionality already built into it, because it not only manages the cryptographic operations of signing artifacts, but it also is a full-blown container OCI attacher, if so to speak. So it's able to read and write things into OCI registries. So it has lots of things in there. The way that we are hoping, and it's almost there. It's already there. To sign things is what we call keyless signing. Not really keyless, but the way it works is that Sigstore will issue for you a short-lived certificate, which you can use to sign your artifacts, and it expires in, 5-10 minutes. The signatures, of course, are verifiable forever, because of the certificate is stored in the transparency log. So even when that certificate is expired, you cannot use it for signing, but you can use it to verify the signatures. This is one of the ways of signing, and it's the preferred way because it's more secure and it's easier, because you don't have to handle any keys. But Cosign also supports all of the various cloud-based KMS systems and the HSM protocol. So if you need any of those, they are there too. Okay. And to sign the image, you just have to basically issue the Cosign sign command, feed it the reference of your image. You have to, so for now, you have to precede, if you want to use keyless signing, you have to precede, you have to set up an environment variable, which is Cosign experimental. Cosign experimental.
The one, I'm assuming.
Exactly. So the reason you have to set that environment variable is because Sigstore is finishing its GA process, so the general availability of the project's infrastructure. There's lots of work going behind that, like everything from writing policy to testing, monitoring of the infrastructure. Everything is being built. The project intends to keep the experimental flag until GA is announced, which should be happening soon.
Okay, and it's saying a lot of stuff. I'm guessing it's saying I'm comfortable with this.
Exactly. Yeah. So that what it's asking you is that some of the information you're feeding into it is going to be stored in the transparency log. So if you're okay with your identity being associated with a signature of the image, then just consent to it, because it's going to be queryable forever. And then it'll present you with this login screen, which allows you to pick from several OIDC providers to prove your identity. And then it feeds it back to Cosign, and it's already signing and pushing the signature. So at this point, your image is signed, and that's all you had to do.
Wow, that's easy.
So we see, here's my image that I pushed, and then a few seconds ago, this thing got pushed.
Exactly.
Which is the .sig.
Exactly. Cosign uses a particular hacky way to attach signatures to container images. And the way it does that is that it creates what we could call an image, which is not really a container image. It's just an artifact container containing the signature. Tags it like that. So it's the digest of your image and appended with a .sig extension. It's not really an extension, it's just a string of the name of the container label. The signature can be uploaded into the registry and associated with your image. And using this way of attaching artifacts, Cosign ensures that it works almost with any registry out there. And so currently the OCI, the Open Containers Initiative, is working on a standardized way of attaching things to container images. The proposal has been accepted, and once it's finalized, Sigstore is going to move its attaching logic to use the new standard.
So now that I've done that, now let's change hats. Let's say I'm somebody else and I want to verify that this image is signed and who signed it. What's the way to do that?
Okay, so it's also really easy. Just Cosign verify and the image reference. I
forgot the experimental.
Oh yeah, you have to do experimental because it's gonna fetch the key from the infrastructure.
Oh, you have 48 at the beginning there.
Okay, we got stuff back. So it's saying claims were validated. Existence of the claims were in the transparency log were verified online and were verified against the full CO roots and a bunch of JSON.
Exactly. Yeah, so that what that gives you back essentially the information about what was signed, and you can also, if you decode the base 64 blob in there, I think it's the certificate used to sign the key.
So the other thing I wanted to try is I'm going to do a container scan against this. What do I call this thing? Live one, and I'm going to output that as JSON. I'm going to dump that to, we'll just call it vulnscan.json. This is doing a standard Snyk container test, same as if you were doing Docker scan. I just want to create a JSON file, and we want to sign this as an attestation of this is what the vuln scan was at the time we ran it.
Yeah, so the cool thing about the testing an image is that you can add information to state something. Using an attestation of a vulnerability scan, you can inform your users that someone looked at this image at a particular point in time and is claiming that is vulnerability free, or maybe or not, or whatever. And by attaching the attestation to the image, it opens up a whole new world of possibilities. Like, for example, if you want to enact policy on that image, or maybe establish, or maybe just do some. I mean, in the case of vulnerability scans, you can do things like, for example, I don't want to trust images that are not scanned, for example, or that have a threshold of the severity of the vulnerabilities contained in them, and things like that.
This is awesome because if you think about it, right, like both of these things work into your CI/CD workflow super well, right? They're both CLI-based tools. So you could actually get a, an SBOM format, because we do SBOM format outputs, and sign and store them, store the signatures. So I think that is just super cool, using Cosign, using all of that. So I think, it's a very valid application, probably something, we'll see a lot of people doing, right? Like signing, validating their SBOMs, so that they have some sort of attestation as far as, what sort of supply chain dependencies they're pulling into their environment. So I think these two things work very well together.
If we run it like this, run it and run it.
I went and exported the experimental because I was tired of typing it.
Okay, I was wondering about that. I was thinking it may be a bug, but cannot see it here just now, but we're gonna take a look. So what it did is it generated the attestation and it stored it into the transparency log. Okay. So to see what it did, just run Cosign, download attestation, and then the image reference.
Wow.
Well, there's a lot of stuff in there.
It's a pretty big file, probably, because it's a very vulnerable image.
Oh, okay. Yeah, exactly. So
let's I'll put this to we'll just say x.json.
I think we entered the matrix.
Cool. Do I need to pipe this? Do I need to base 64 to code this? I'm guessing.
Yeah. Yep. You can do that.
So we're gonna do. What are we looking for?
JQ, then dash R. I think it's for row, just to strip it of the quotes, and then dot payload.
64. Do you have to put a dash D?
Dash D dash.
And that's JSON. That's
and repipe it to JQ to format it.
Again, it was a big vuln report.
Yeah. So what we're mostly interested in right now is the topmost part of the. Is that okay? Yeah. So as you can see, it's an in-toto statement. So Cosign uses the in-toto format for attestations. In-toto is a great open source project which is geared towards securing the whole supply chain of software projects. Highly recommend. It's under the CNCF umbrella as well. If you see it under the predicate type, it uses the Cosign generic attestation. Cosign supports different kinds of different types of attestations. There's one for a vulnerability scan, and there are also SBOMs. There are SBOMs in SPDX format, in Cyclone-DX format. Then you can see the content of the actual security scan that Snyk performed under there. It should be and that's the payload that gets signed and attached to the image. So whenever you are working with that image, you could potentially query to see if it has been scanned for security vulnerabilities and ensure that it's coming from who is supposed to. On Kubernetes, we're still working on the signature cap. We already have container images signed, but we're working on the attestations that we just saw. And we are also working on signing the binaries that we put out. So if you want to help the project and this is a subject that interests you, jump on the SIG-Release engineering calls and say hi, and we have some work that we can give you.
Thanks so much, Adolfo, for joining us. Kyle, any other parting thoughts?
It seems like Sigstore's having a conference as well. So if you're very, very interested in signing all the things, you should definitely check it out. So thank you, Adolfo Garcia Veytia, for coming on with us today. Thank you so much, Eric Smalling, for bringing this wonderful guest on. I am super honored that I got to speak with y'all today and ask all these questions. And, I think chat really, really liked what we put out there today. So yeah, if you like content like this, make sure that you're following the Twitch channel. If you're on YouTube, make sure that you subscribe. Adolfo, I'm sure this isn't the last we'll be seeing of you. It sounds like we can definitely talk for hours and hours about this sort of stuff. So hopefully we'll have you back very, very soon. Thank you so much for coming on, and have a great day, everyone.